so let's start for today's class. So I think, just in case if anybody walking into the wrong classroom, this course is powder metallurgy, powder technology, something related to powder. So this is a course that's offered in graduate level, but as again I expressed to those undergrad students sitting over there is I am open-minded for anybody that wants to take this course without any prerequisite, okay? So if you have no background or you are non-engineer related, that's totally fine for taking this class, okay? That's first thing. Second is, the most important, my name is Professor Tsai. You can call me Dr. Tsai or Professor Tsai, any way you feel comfortable. So currently I am a professor in the Department of Mechanical Engineering in the Material Division. So as you, well, I assume everybody is in the mechanical department, but if you are not, to give you some little background, is our department actually is the most biggest department in NTUST. Our department actually has 5 different divisions, as you probably know. So we have quite some people, as I know, is from the manufacturing division. But somehow right now I'm in the material department, material division. But again, is all of the divisions, what I'm trying to say is that I again welcome all the people that isn't actually in the material divisions, non-related background to take this class, to give you some some idea of what powder technology or powder metallurgy actually is. So, getting today's, basically this week's objective. So as you probably know by now, is this semester is a 16-week semester, right? 16-week. Now, if we do some deductions, including the midterm and the finals, basically we're left upon 14 weeks, 14 weeks. I think the first important message I want to convey to all of individual of you guys is that this class is not a very typical class. What I mean by that is that this class is not a traditional where I stand here and start talking all the stuff. No, actually it is not. So this semester is actually, I have invited a lot of different experts in this field, not only limited to powder technologies, but somehow related to powder technology. So you will actually be exposed to a wide spectrum of people that's related to powder technology, okay? So for this, once we do a deduction of midterm and final, we're left upon 14 weeks. You'll probably see me giving you lectures about once or twice or maybe 3 times. And the rest upon is different people that I am associated with them, I am invited them to come. And it's somewhat a content of a seminar content, okay? So again, I emphasize it's a seminar content where they give the courses. So that's the most important. So I will keep emphasizing that I really hate giving out classes, and I actually do not like giving out exam. For those undergrad that already took my fundamental of material, is that I really hate that curriculum. I also hate that structures. However, I am obeyed to follow that curriculum because the school is paying me salary. Nonetheless, right now we're in the graduate level, so I have more the flexibility to do whatever I want now. So that's actually what I want to give you. So if you feel uncomfortable, you feel unsatisfied taking these classes, please do not take this class, okay? Because we definitely will have the midterm evaluation and final evaluations. Hopefully this doesn't come up as an issue as we further go along during the semesters. Okay? Right. So now I have actually asked my graduate students. So my graduate student, which is, you are very diligent. They're all sitting in the front. Good for you guys. And then those are sitting in the back. That's okay. I also love you guys. But I asked my graduate student to do a video recording of me. Well, not me, but everybody, participant, the lecturers and instructors that are giving classes. So if somehow you feel stressed or understanding me speaking or other following instructors that's speaking. As again, this class is in an EMI. So we, again, are supposed to talk in English, not Chinese or Mandarin or other, blah, blah, blah languages. So we are supposed to talk. And again, for those graduate level, and especially for undergrad, speaking English is an international thing, right? That's a default. I think I encourage you to really, speak up, right? Encourage you to do your talking and stuff. So this current right now is recorded. Okay, and then once we record it, I will upload to Moodle. So if you feel want to review the course's content, you're more than free to do so. So do not use that as an excuse that, oh, I have issues about English, blah, 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 blah. No, that's an excuse. I already recorded, so you can listen 10 or 100 times, okay? As much as you want. All right? Any questions so far? So again, my name is John T. Tsai, and then I have my email. It's very simple, TSAI, that stands for Tsai, and then J, and then @mail.ntusd.edu. So just a little bit background about me. As I expressed, I am from the Department of Mechanical Engineering in the Material Divisions. I have my telephone with me and mail. Oh, so for those that already know me, bear with me. For those that doesn't know me, you probably know that I respond email within 6 hours, or even a very short amount of time span. So you can ask my graduate students, usually they can reach out to me. It is not an excuse to say that I don't, contact. You can ask those undergrads, usually I respond emails or even text messages within 1 hour. So I am very fast at responding, okay? My lab is currently called Multifunctional Material Manufacturing Laboratory. I give a acronym of 3M. Okay, so a little bit background about me. I currently hold a PhD degree in material engineering at Purdue University. So I won't go into detail. Well, actually, I'll show some little bit image about Purdue University, but I'm not going to go into telling you, what is Purdue. Okay. Experience. Currently assistant professor at NTUSD in the mechanical department. I did my postdoc at Argonne National Laboratory. For those that doesn't know, Argonne National Laboratory is the same or analogous to Zhongyuan, okay, or any other research facility at Taiwan. So did about 1 year at Argonne National Laboratory. So if you need a little bit background on Argonne National Laboratory, in USA there's a lot of national laboratories. Each of these national laboratories has their initiative, mission, objective. Argonne National Laboratory was originally built to facilitate building a nuclear bomb. So at that time during World War II, when they were fighting with the Japanese, this is where the nuclear program, I think there was a movie some while ago, a few months about, what's the movie? Oppenheimer? Yeah. So they basically joined coalitions with different national laboratories. So Argonne National Laboratory at that time was tasked to do metallurgies, for building the structural integrities of atomic bomb. But regardless, other research facility actually laboratories they do chemistries and etc. Good. All right. So bottom left over here is my research areas. I actually have a wide spectrum of interest of doing research, so please do not stop you from reaching out to me simply because I'm in material divisions. As you know, that I actually are very interested with everything, meaning everything. So here's just a list of some bucket lists of stuff I am mostly devoted to doing additive manufacturing. Yes, I am very passionate about doing additive manufacturing, and yes, this is because money, cash is coming from, so I have to do additive manufacturing. However, at the end of the day, if I'm given to a second option of doing other stuff, I will. Okay, so first, I do additive manufacturing. Second, my expertise, I do cold spray coating. So what is cold spray? Well, yes, it is it's an opposite side of a solar spray. So cold spray basically is commonly widely used, traditionally was to do MRO, so material repair operations. So as you can see, for those that have a material background, we always like to do its process, microstructures, and property relationship, right? But oftentimes, once the material fractures, what do? We throw it away, or maybe we recycle, right? So this is where the cold spray come in to do its repair so that we can again reuse the component of the material. Okay, so I think next, well, it's not I think, for next semester, next week, I will dive in a little bit what cold spray is, what some of the key component when you make up cold spray, and how do you actually use cold spray to fix stuff. So that's one thing. Okay, so third part is composite material. So I actually have 2 master's degrees, so another stuff we're doing about composite material. So when I say composite material, I'm not referring to metals or ceramic to polymers. Actually, I'm meaning traditional materials that involve carbon fiber reinforced polymer plastic. So short carbon fiber, long carbon fibers, the matrix is the resin. So that's it's composite material that I'm referring. Okay, so you can have carbon fiber, you can again also have glass fibers as well. So glass fibers with matrix as resin. So ideal about that. So oftentimes people that do composite materials, I know in the structural divisions, there are also other professors that do that. Like for example, Professor Wang Songren, and I think in manufacturing is Professor Clark Ward, he also did composite materials, so that's what I'm referring to. Right? So non-destructive testing, structural health monitoring, CFR fabrications, and polymer testing are all sort of fall in the bucket list of my expertise or research interest. Right? So on the right hand side is academic research award and honor. I won't go into detail about that. Alright, so this week basically what I'm going to do is just kind of show a little bit more about me, and in case if you already know me, be patient. Always it's good to know more about your instructors. All right, so then you can get good grades, right? All right. But if you don't know me, I think it's a great time to kind of showcase what exactly my personality is, right? This help you along the way because after you graduate, you'll work with a team, with a boss, right? You definitely want to make him or her happy, right? All right, so this is me standing in front of the cold spray during my PhD. Well, for those that's doing PhD degree, you'll probably know more. So during my PhD, I was tasked upon building a cold spray. But that was my job. So you can see I'm standing in front of a robotic arm that's holding a cold spray system, and then at the back is a downdraft. So at that time, I was tasked to do that, and that's me. All right, so a little bit on the second picture here, I'd like to show is a Purdue campus. So a little bit more detail about Purdue campus. It's the Big Ten. When they say the Big Ten, meaning that is the biggest campus in the United States. So there's 10 big campuses. Purdue is one of the biggest campus in the USA. To give you some idea about when I say big, is that within each of these buildings, when you need to take a class or do experiments, you actually need to drive a car to get to your destination. So you can imagine that. So of course, there's no one stopping you from walking, but usually walking take approximately 15 to 20 minutes. So think about that. So getting a car is, I would say, is inevitable. So do not get, this picture is kind of deceived. So do not get deceived by this building. This building is it's very close. Actually, it's far away. All right. So I don't have a cat right now. During my PhD time, I actually was also tasked upon raising a cat. That was my landlord's cat, so I had to take care of this cat as well. During my leisure time, I actually like to play badminton. That's one of my favorite activities. So, do I have more audio pictures? Yeah, so these are only the 2 pictures I can give you, so a glimpse of what our National Laboratory look like. This is as much I can show you, okay? Because a lot of stuff inside is confidential. So left-hand side is in the front doorway of our National Labs. Once you start walking, they have security guards. In the past, they hold guns. Guns, I'm not joking, guns. Be ready. And then you need to check the security point to get in. But now they have taken that. They're more human, right? So they don't have guns. But I feel very stressed every time when I go to check. So this is the Oregon National Lab to really show you that I did really go to Oregon National Lab, okay? And on the right-hand side is the most important facility at our national lab called the synchrotron. So in Taiwan, at Hsinchu, we have synchrotron as well. But this is one of the biggest and the most famous being used synchrotron in the USA. So what this actually is on the middle over here, they have a very strong X-ray light. What this X-ray light, it actually has immense intensity of the X-ray energy that go within in this circle for many, many times. And you can see they have windows over here. So each of these windows we call sectors. So each of these sectors actually, once these synchronon energy that goes spiral around in this circle right now, they took upon each of these different energy, well actually energies would degrade because continue to rotate, right? And each of these windows is a sector where they kind of taking out some of the energy out for different purposes. In other words, different functions they do. So some of them they do tomography, some of them they do like just general X-rays, some of them they do biologies and etc. So I'm not sure if they have 32 or 36 sectors. So if you really do have a chance to go to Ahon, this is the most famous site. Again, to give you some glimpse of how large this facility is I actually was once inside this circle many times. It took about 1 hour to walk inside this facility, 1 hour. Walking in a fast pace, okay? So a lot of times inside of here, they actually ride a bicycle to get to other checkpoint. That never would happen in Taiwan Hsinchu facility, okay? So that's how big it is. So quick glimpse, I actually do a lot of leisure activity. I'm the person who like to do work-life balance. I don't really like to stay in the lab to showcase I'm so diligent that I work 24 hours per day, 7 days per week, and 30 days per month. Actually I do not. I promote a lot of leisure activities. You're gonna ask my lab students, so I do kayakings. There was last year, summer I went to Japan. So after when I was done teaching phase transformations, I had enough. I went to Japan. So it was a long break for me. All right, so for those that already saw this, great. Again, this is somewhat a research I've been doing in the past. Right now, I just started building my lab, but eventually we will more tilted toward this. Right now, our lab focuses on additive manufacturing. When we talk about additive manufacturing, it also involves about powders, right? So that's why powder is such an important thing we need to spend some time to talk about, right? And over here, MRO, we have 2 students dedicated to doing this, material repair operations, stand for MRO, you fix materials, right? This is such an important thing. Nowadays, the governments, the people oftentimes talk about, we need to save energies, and carbon emissions and so on. We need to, save the ocean, save the penguin, save the polar bear. Why not start from saving the materials, right? So think about this. This is logically that makes sense, right? Because if a material that's broken, if we can somehow again regain its maintenance life cycles, then maybe we save a lot of investment, right? So this is on the right-hand side. So I do a lot of simulation and experiment as well, okay? Structural health monitoring on the left-hand side of the view. Basically, the way that I do my structural health monitoring is basically by using the fiber optical sensors. The ways, the hows, the what, the how I do it is not important, but I want to give you some idea of why structural health monitoring is such important. Because let's put it this way: is if you take I think a lot of guys rode motorcycles, right? Yeah. So if you drive a motorcycle, bicycles, these parts tends to wear out within some time, some mileage, right? You need to change the oil cuttage, you need to change the oil, etc. Right? So within a certain amount of mileage. So I think it's these usually the technicians will tell you within a certain mileage you need to change. There's no saying like, oh, I don't want to feel changing. I mean, unless you go walking into a motorcycle shop. They will say, oh, this mileage you need to change, right? All right. So structural health monitoring basically it comes in to tell you what exactly is the time. We give you more science number, right? It's not much of a feeling. Okay. The reason why for certain mileage, for example, 5,000, 2,000 mileage that you change was simply because it was an average estimate from previous
their report or technology they have done, they did an average, so they tell you that, oh, within this mileage, we need to change. The same scenario that goes into motorcycle is same as the scenario where you do aircraft, flights, planes, cars, or submarines, all these parts. So structural health, most of the things is being doing on structures, materials like bridges, big, parts like a reservoir, and a lot of it in military stuff, right? Because a lot of these components, when that change, it's quite expensive, right? It's not like riding a motorcycle. So that's where structural health monitoring comes in. All right, so syllabus is, I think, another important. I will post all of these information on Moodle, and hopefully this week you can spend some time to review what's the syllabus and then be familiar with that, so that there's no surprise after we start the weekly progress of each of these other technology. All right, so these are the textbook. I still will talk about a little bit about phase transformations. Book, I used Art and German. It's about the methodologies, and you can go and try to find this book. And I also use a little bit about material science, some background. So it's from Callister. So these books are great book. If you can get the book, great. If you don't, that's fine as well. I'm just going to use lecture content to give you that. All right. Office hours. If you want to come and find me or talk to me, or if you have other problems, by email or comment. Again, I usually respond to you within 6 hours or even quicker, less than half an hour. Also for any grade of students who want to take homework. Do we have homework? No, we don't have homework. I don't give homework, so no homework. Okay. Now, exam. We do have exam. So this is a comprehensive exam. So what happened right now is I'll show you I have the next page that shows you what's the same. So this exam, the comprehensive exam, is a multiple choice questions. That's about 20. I'm still thinking about it. So it's a multiple question. So this counts you the total about 30%. So grading over here, comprehensive exam is 30%. So 30%, and then write a term paper that's 70%. So writing a term paper, once you follow the instructions, normally you will get about 65 to 70% of your grade if you do it correctly. So again, writing a term paper is follow the strict guideline, right? Do not be creative, right? Last 2 semesters ago when I was teaching phase transformations, there was a lot of students that being creative of writing a term paper. So writing a term paper, follow the instruction guideline, that's 70%, and comprehensive exam of 30%. So here is the takeaway. Is if you follow this, it's a very easy A for this course, for this class, right? So I do not understand what's stopping you from getting an A. So if at the end of this class, once I review the grade, I find someone that doesn't get an A, I will personally invite you to have an interview with me and explain what were you doing. You must be a very intelligent, smart guy. Okay, all right, does that make sense? All right, this is the syllabus. I don't know if you guys can see the syllabus. Okay, maybe a little bit too small, but I will post this. This is not final. This is not final. So you can see we have a wide range of topic. So topic over here, actually I put the top, what they're going to talk about over here on the right hand side. But over here, I invite a wide range of people. So this week is week 1, right? It's a course introductions. Next week, I'll talk about the spray, about the powders. This will be week 3, talk about rheology. So this might change. There might be, I invite another instructor to talk about. And then week 4, Dr. Lee will talk about XRD. So he's from Melbourne, Connecticut. So XRD, talk about how do you use XRD on your specimens. For those in the material division or maybe in manufacturing divisions or they do XRD is important because they get to know its microstructures, its structures, right? Here's my personal opinion. I really don't like people just giving me some plots of lines and telling me this is like this is some material. All right, there's more information you can get out of XRD spectrum than just fitting the peak and telling me, okay, this is the material. Okay, that's really boring. So again, Dr. Lee, I know him, so I know him, so he will give you some insight that what you can use for using XRD instrument. I think it will be really benefit for you, because rather than spending one semester of taking XRD, we'll give you like 1 hour of like condensed how XRD can give you all the information. Hey, that's really time efficient, right? You can ask more than this, right? I'm giving you one hour to give you what you can do for XRD rather than you spending like a semester getting an XRD class, right? Man, this is worth the money, man. Come on. Right. So I also invite week 5 my former master advisor over here. He actually recently retired from this university, Li Sun-Tian. So Professor Lin will come and actually talk about powder injection molding. Again, it's a 2-hour to 3-hour lecture. He will give you a very condensed about what powder injection molding has come upon, what's the recent thing happening, so recent technologies in 3 hours. So very condensed. Okay. So if you ask me, is there going to be a lot of theory in this class? No, that's a no. But is there a lot of what you can do using this tool to get the information? That's a yes, right? So I think it's very exciting. So the following week over here, basically we have Professor Huang. So Professor Huang over here will talk again about the injection molding. So he currently works in an industry. He has opened up a company that do powder injection molding as well. Mostly he's based in China. So he will give you actually a lot of current spectrum of what powder injection molding has gone on, right? A lot to do with powder. So again, moving forward, on week 9 of you, I'll come back and talk about phase transformations. I think although it's powder will also deal with phase transformation as well, right? If you talk about materials, there will be material structures that change accordingly with time and temperature, right? So I'll talk a little bit about that. Again, these kind of listed right now, it's not fixed. It will be slightly changed according to time. But these people, of course, they will be showing up. Alright, it's just the time right now is kind of a little bit kind of fuzzy. Mr. Yan will talk about additive manufacturing in ceramic material. So for those, I think when we were in manufacturing, who's in the manufacturing division, by the way? I kind of forgot. You're in the manufacturing division? Only you? Both 3, right? And who's from you, right? Yeah, good. So especially because you're with Professor Chen, right? Yeah, I have weekly meeting with him, like, so it's actually quite benefit because we'll invite Professor Yan. He will come and talk about ceramic material and additive manufacturing. I know Professor Chen's research recently presented zirconium oxide for using DOP for additive manufacturing. So yeah, so it's going to be benefit. Right? So over here, powder injection, and then on week 13, right now I've identified who's the person, but MODEX review will also come. In case you don't know what MODEX is a simulation software, same as Pro-E, AutoCAD, ANSYS, and blah, blah, blah. So what it does is it can do fluid simulations, but not in a very high dynamics, but rather it's slow. So what it do is particularly dedicated for powder injection molding. So this person will actually spend some time to talk about the technology. Okay, so week 14 right now, TBD needs to be designated, but I think over here, I also invite one of my colleagues that's currently working, not the colleague that we have sushi, okay, so it's other colleague that's working in industry, currently in the semiconductor industry. He will come in and talk about what's the current job scope and what's the research technology of using TEM. If you don't know TEM, that's fine, but he will talk about semiconductor. All right, so you might ask why I am bringing a person to talk about semiconductor. Is I don't know if you guys know that recently in Taiwan that probably 8 out of 10 people, for those that graduate, end up working in the semiconductor industry. Right? If you like it or not, it's a trend. And then a lot of universities right now is opening courses that's related to semiconductor. So I think I invited my friend to come in to give you what's the truth about semiconductor. What does it feel like working in semiconductors? And what actually is the thing behind the curtains? Right? Because oftentimes when the HR that represent from the semiconductor will give you an image of it's a great life, right? Good money, great benefit, let's come and join semiconductor. But once you join in, it's like, it's not what you think. That's what I believe is important. So my colleague that come in will really give you an idea and give you some, time to think about before you graduate. Right? For those, I think that once you graduate, you're trying to find a job. Right? Yeah. Right? So I don't think that once you graduate, you'll retire. There's nobody taking the set they retire. Right? That's another different scenario. But if you're going to retire after taking these classes, so come and talk to me, let me know about it. I also want to know how to retire after teaching. Right? But anyway, I think it's fair to invite my colleague. All right. So week 15, we won't have class. This entire semester, this class is on Tuesday, right? So regardless of like Dragon Festivals or Lunar New Year or whatever, none of these coincide with our classes, so we'll continue to have. So week 15, we're just this class will be off, we won't, and then week 16 we'll have a final exam. So the comprehensive exam is a multiple question of probably 25 to 30 questions. Each of these questions come from the lecture instructors. Okay, it's a multiple questions. No rhetorical question. When I say rhetorical question, I mean that you have to write like a bunch of sentence or paragraph. No, it's just A, B, C, D. It's A or B or C or D. Okay? So 25 to 30, it's very, very straightforward to that. Okay? So week 17 is where I'm gonna submit my final grade submission. Okay? So if you have, actually on week 16, I will have all the grades ready. So week 17, I'm gonna submit it. So do not come to me on week 17 telling me that you have issues without your grade. Right? That's not gonna happen. So week 16, once we have the test, I'm gonna do the grading and then I'm gonna submit it. So please do that way ahead of time. All right? Questions? Questions? Oh, by the way, in this class, you're more than free to eat, sleep, or dress. Well, dress casually, right? Dress appropriately. All right. So if you want to eat, you're more than welcome to eat sandwiches as long as it doesn't have smell, right? So no stinky tofu, no like cheap pie. That's okay. But like you're more than welcome to eat sandwiches as long as it has smell. So you're okay to drink. You can drink bubble tea, whatever high sugar content, as long as it doesn't affluent to affect anybody. Great. Sleep-wise, yes, you can sleep. All right. If you want to sleep, please go ahead and sleep. It's your right to do that. I won't stop you from doing such a thing. All right. Great. And then lastly is this class I am really relaxed. I'm a very casual person. Those that doesn't really know me, you can ask my graduate students, you can approach me very easily. I do not have any things to stop you from reaching out to me. All right, so you can come and talk to me anytime. Right? Now, if you can come to this class, again, there's sometimes, like I know Professor Horn has mentioned, your professor, your advisor has told me, so sometimes you have other conflict, right? I think it is your right and you telling me that, oh, you cannot make it for this class, right? It shows you that you're a mature person, right? So please be a mature person. I encourage you to be mature. Do not be like a children. But sometimes you doesn't show up, sometimes you show up. Again, you guys are engineering students, right? So be like an engineering students. Be like a mature person, right? Be a person, that's a minimum, right? For the last year, what I have seen for a wide different spectrum of students, a lot of them actually is quite appalling, very shocking the way they behave. So I always encourage my graduates in the sense of those that isn't fall under my umbrella is I encourage you to be a mature and professional person. Be on time, be courtesy, respect other people. These are general human things that you ought to be, or else there's no different from you between an animal. All right? Hopefully I've convinced you. Does it make any sense? Make sense? See, sometimes I wonder, like, when I talk, do you guys understand? All right, now you guys good. Like my graduate students, I think they have, interacted with me for the past year because like if they don't understand right now, they probably already drop as my advisor, but they're doing fine. You guys are okay? I'll think I know you guys you should be fine, right? Good. You good? All right, great. All right, so the subject over here, these highlighted in red is how you're gonna write the term papers, right? So this term paper actually is count as a total of 70%, right? But the way that I'm gonna do this is try to help you to write this term paper, all right? So I won't. The plan we're gonna do is now I'm not gonna be at the end of the semester and ask you to submit a term paper. Actually, we're taking this very slowly. So we're doing this together so that at the end you have a term paper you can show. So this first thing is first we'll do a half-page proposal. This is due. I'll explain a little bit later. So you have a half-page proposal telling you what you're gonna write. So again, this is helping you to not give people a surprise, right? So this half the proposal, you're proposing me what you're gonna write so that I can review to tell you that does this make sense or not, right? So you write that half page, that's it, right? If not, I'll return to you and tell you what makes sense and what doesn't make sense. Second is we'll list a six references. Again, this is a term paper, or if you want to say this is a review paper or report or writing, whichever, that's fine. But we need to have some citation because you're writing this paper, you're not doing an experiment. I reiterate, this is not you writing a term paper that associate you doing some experiments in the lab. Again, this is a term paper, or if you want to say this is a review paper, it's the same thing, right? So once you write a review paper, there is some references you're looking upon, right? You're reading some references. So what's the 6 references you're looking into, right? So minimum 6 references, and you have to cite the references and tell me why are you citing these references. So again, later later I'll talk about how you're going to do the references. So outline. So how do we do the outline? So there's an outline like, where first you have introductions and material method, and then results and then conclusions. So some of my graduate students have really somewhat gone through this a little bit more, right? You have gone through this a little bit more, but others haven't, right? I think it's crucial to really spend some time to talk to you how we can do this in a more professional way. All right. So for the past year, I have suffered enough of different content, inconsistent and etc. It's really painful. So I think going through this process will help you and also help me internally. Right. Term paper is when you do. So term paper is due on week 15. No excuse. Right. Did the bell just ring? It's a recess time. All right. Let's have 10. Is this 10 minutes or 20 minutes break? 10 minutes, 20? 10? All right. Let's have 10 minutes break when we get back.